Every day we interact with a world powered by invisible information highways. Behind every message, movie, or AI answer is a vast physical infrastructure working non-stop data centers. These facilities are the backbone of our digital lives, storing, processing, and moving the data that defines our age. When you post a photo or ask for directions, your request travels to a real building filled with powerful computers. These operations generate immense heat and consume huge amounts of energy. Data centers are not just warehouses, they're dynamic hubs where digital magic happens, but with a real environmental cost. Let's pull back the curtain and explore how these digital factories work, why they're growing, and what it means for our planet. By the end, you'll see your digital world in a whole new light. So, what is a data center? It's a specialized building packed with servers, powerful computers stacked in racks, that store, process, and deliver digital content worldwide. Think of it as the physical home of the internet with massive support systems, backup power, high-speed networks, and tight security. Data centers centralize computing power, storage, and networking, creating efficiencies that make our digital world possible. Instead of every company building its own server room, they rent space and power from these professional facilities. This is the essence of the cloud. Giant companies like Amazon, Microsoft, and Google renting out computing power globally. Without data centers, the internet as we know it wouldn't exist. They are the unseen factories behind every digital service. From the moment you wake up, data centers power your day. Your alarm streaming music, checking messages, or scrolling social media, all connect to servers possibly thousands of miles away. Streaming podcasts, using navigation apps, sending emails, ordering food, or watching Netflix. Every action relies on data centers. Even a simple video call or an AI chatbot response is processed in these digital warehouses. Content delivery networks ensure your videos stream smoothly, thanks to a global web of data centers. From morning to night, these hidden powerhouses are your silent partners in every digital task. They make modern convenience possible, everywhere, all the time. Data centers are the invisible infrastructure of our connected lives. Inside every data center, servers are powered by processors, the brains of the operation. CPUs are generalists, handling a wide range of tasks quickly and efficiently. The rise of AI brought GPUs into the spotlight, specialists at performing millions of parallel calculations, perfect for training AI models. Now even more specialized chips like NPUs and TPUs are designed solely for running AI with maximum efficiency. All this computing generates tremendous heat. Imagine thousands of ovens running at once. Without powerful cooling, these processors would overheat and fail. Cooling isn't a luxury, it's a mission-critical necessity. The faster the brains work, the hotter they get. Managing this heat is one of the biggest challenges in data center design. The AI boom has transformed data centers into energy-hungry giants. Training large AI models takes weeks of non-stop computation on thousands of GPUs, consuming staggering amounts of electricity. High-density AI racks can use 10 times more power and generate 10 times more heat than traditional setups. These AI factories are often built near major power sources, sometimes rivaling the energy use of small cities. The environmental impact is huge. More power means more emissions if not sourced renewably. And more heat means more aggressive cooling. This has also increased data centers' thirst for water, creating new environmental challenges. The move to AI has made data centers bigger, hotter, and much more resource-intensive. Managing their appetite is now a global concern. Cooling massive data centers often relies on water, not just air conditioning. Evaporative cooling uses water to absorb heat, much like sweating cools your body. Air passes through water-soaked pads, evaporates, and cools the server rooms. This method is energy efficient but consumes significant water, especially in dry regions. The industry tracks this with water usage effectiveness, WE, how many liters are used per kilowatt hour of computing. Some data centers are efficient, but others, especially in arid areas, can be very thirsty. The ideal locations for data centers often clash with local water scarcity, creating tough trade-offs. As data centers grow, their water demand is becoming a major environmental and social issue. Training a single large AI model can consume hundreds of thousands of liters of fresh water for cooling. Even using an AI chatbot has a water cost, about half a liter per 20-50 question conversation, according to recent studies. Multiply that by billions of queries and the water footprint becomes enormous. This water is not returned to rivers, it evaporates and leaves the local ecosystem. In drought-prone regions, diverting millions of liters to data centers can impact agriculture, wildlife, and communities. The invisible cost of our digital lives is measured in water bottles, and sometimes, entire reservoirs. As AI usage explodes, so does its hidden thirst. Our digital convenience comes with a very real, physical price. Measuring the exact water footprint of AI is complex and uncertain. Location, cooling technology, weather, and hardware efficiency all affect how much water is used per query. A data center in cool Ireland may use little water, while one in hot Arizona uses much more for the same task. Newer, more efficient AI models and processors can reduce water use, but growing model size often offsets these gains. Most companies keep detailed water and energy data secret, so researchers rely on estimates and limited public numbers. Without transparency, it's hard to hold companies accountable or drive real improvements. The true water cost of AI is a moving target, shaped by technology, geography, and corporate secrecy. Better data and reporting are urgently needed. The half a liter per chat estimate made headlines, but it's just that, an estimate. Real-world water use varies by data center efficiency, location, and the complexity of your AI request. Some companies argue that smart cooling systems and dynamic methods can lower average water use per query. The true answer is a range, not a single number. What's clear, running powerful AI models requires immense energy, which generates heat, and cooling that heat often consumes water. Whether it's a bottle or a glass per chat, billions of users add up to a massive strain on resources. The debate highlights the need for better data and standardized reporting. Our digital choices have a real-world impact, drop by drop. Data centers' impact goes beyond water. They're huge electricity consumers, using up to 2% of global power. Unless powered by renewables, this drives carbon emissions and strains local grids. New data centers can add the energy demand of a small city, raising questions about local benefits versus environmental costs. Water use sparks conflict in drought-prone areas, sometimes leading to legal battles over scarce resources. Data centers also produce electronic waste. Servers have short lifespans and must be responsibly recycled. Their physical footprint is massive, occupying large tracts of land. From energy and water to waste, data centers are a major industrial force with a growing environmental impact. The digital world's convenience comes with a complex, real-world cost. Some dream of launching data centers into space to solve Earth's power and cooling challenges. In theory, space offers cold temperatures and endless solar energy, reducing environmental impact, but cooling in a vacuum is tough. Heat can only escape through radiation, requiring massive radiators. Launching thousands of servers and maintaining them in orbit is prohibitively expensive and risky. Repairs would need complex robotics or astronauts, making operations far costlier than on Earth. Space debris and radiation add more hazards. While fascinating, space data centers aren't a practical solution anytime soon. The real challenge, and opportunity, remains here on Earth. The future of sustainable computing must be built on Earth, not in orbit. We need cleaner, more efficient, and transparent data centers. This means designing better processors, smarter software, and facilities powered by 100% renewables. Advanced cooling systems that use less or no water, and responsible siting in water-rich areas, are essential. Companies must openly report water and energy use so communities can make informed decisions. A circular economy, longer-lasting servers, recycling and reusing waste heat should be the goal. The future isn't about escaping Earth's limits, but innovating within them. Our digital infrastructure must work in harmony with our planet. Data centers may seem distant, but their impact is real, and you can help shape their future. Stay informed about the environmental costs of your digital habits. Support companies that are transparent and committed to renewable energy and water conservation. Use your voice as a consumer. Ask questions and demand better practices. Advocate for policies that require reporting and responsible growth. Our collective choices and pressure can drive the industry toward sustainability. The journey to a greener digital world is ongoing, but every action counts. Let's change the world, one bite and one drop at a time.